The whole point of learning about logs and exponents is to actually use them to solve equations. So now we're going to look at applying them to engineering problems. We will do these three problems by the end of the class, one during the middle and two at the end. A non-exhaustive list of what you can use indices and logs for. They are used in modelling all of these sorts of things: the discharge of a capacitor, radioactive decay, inductive circuits, capacitive circuits, etc., etc. They are everywhere. Richter scale, Newton's law, decibels, pH, exponential growth, exponential decay are all modelled with logs or exponents. Here you're given some information about logs, and you're given the formula whereby we can work out the magnitude of an earthquake. So the magnitude is equal to the log of the intensities of two earthquakes, or else the log of the intensity of an earthquake over some constant. Okay, let's look first up at the magnitude of the earthquake in San Francisco. What we're told is that it's equal to the log to base 10 here of the intensity of the earthquake in San Francisco divided by some constant. And we're told that that's equal to 8.3 on the Richter scale. We've also got some information about the earthquake in South America, that it's using the same formula, equal to the intensity in South America divided by some constant. And that's something that we don't know. But what we also know is that the intensity in South America is equal to 4 times the intensity in San Francisco. Okay, now we've got two equations. Let's treat these as a pair of simultaneous equations. Let's call that equation 1, and let's call that equation 2. And let's work out what happens if we go equation 1 minus equation 2. Right, so we get 8.3 minus the magnitude in South America is equal to the log of the intensity in San Francisco over some constant minus the log of the intensity in South America over some constant. Okay, what do we know about subtraction? Subtraction is the same as division, so that becomes log to the base I SF over IO over ISA over IO and the IOs cancel out, and using the thing that we know, which is that ISA is equal to 4 times ISF, we can rewrite that as it's being the log of ISF over 4 ISF. Well, that makes things a lot easier. Now we've got that 8.3 minus the magnitude in South America is equal to the log of 1 over 4. From there we're nearly done. Simple rearrangement will now show us that the magnitude of the earthquake in South America is equal to 8.3 minus log of 1/4. And if we use our calculators for that, we find that the magnitude of the earthquake in South America is 8.9. Quite an earthquake. First question, pressure P in pascals at a height of h meters above the ground level is given by P equals P naught e to the negative h over c. And we're given what P naught is, we're given the height, and we're given the value of c. So all we have to do is put the figures in to find P. So it will be 1.012 times 10 to the 5 times e to the power of negative 1420 over 71500, which is equal to 99.20998 times 10 to the 3 pascals. Or you might be writing it as 9.921 times 10 to the 4 pascals. The first part of this question is a plug and chug. You need to find the voltage when t is 160 times 10 to the negative 6 seconds. So you simply put that into the formula. The second part is the more complex part. We know what the voltage is, so we can use the formula to say that 85 is equal to 200 e to the negative 150 t over 12.5 times 10 to the negative 3. Right, we're looking for t, so if we divide both sides by 200 and then take the natural log of each side, like that, and if we rearrange it, t is equal to the natural log of 85 over 200 times 12.5 times 10 to the negative 3 divided by negative 150. I think that's meant to be negative 3. And push that through your calculator and you get 71 seconds. A typical exam question where the first part is basic, it's just basic substitution. You're given the numbers and you just need to put them in. So putting the numbers that are given into the calculator, we get that L naught is 1.993 meters. Second part again is the more challenging one. We're told that the length is 2.416 and we have to find L naught. So put in 2.416 is equal to L naught times e to the power of 1.682 times 10 to the power of negative 4 times 310. And then rearranging that gives us that L naught is equal to 2.416 divided by e to the power of 1.682 times 10 to the negative 4 times 310. Calculator job,